All right, we are on page 410, and we're going to be going through 412 and our assignment on 413. So we're finishing up this lesson on activity 5 and talk the talk. So we worked on identifying functions of tables, sequences, sets of ordered pairs, and mapping diagrams, and then also graphs. But we haven't done it with an equation. The equation is a little bit more work. The other one's probably not too much computation, but this one there will be. So for this worked example, in order to determine if an equation is a function, this says, right, so you can use the equation y equal to 3x to convert yards to feet because there are 3 feet for every 1 yard. To test whether this equation is a function, you first substitute values in for x into the equation, and then determine whether any x value maps to any one y value. And then when one x value has exactly one y value, it is a function. Otherwise, it's not a function. We can find a counter example. So here, right, if we plug a 1 in for x, right, 3, we'll have to multiply by 3. So 3 times 1 is 3. And keep going, right, 3 times 3 is 9. And we'll get 4 times 3 is 12, 8 times 3 is 24. Okay, so when we look at this, after we plug in these x values, are they a function? Does every input have one output? In this case, it is yes, right? 1 has one output, 3 has one output, 4 and 8 each have one output. Okay, so here, this is an important thing to notice. It is impossible to test every possible input value to determine whether or not the equation represents a function, right? We'll most likely just plug in like maybe 3 values and try to see if there's an example or counterexample from that. But it says you can graph any equation to see the pattern and use the vertical line test and whether it represents a function. So there's other ways of going about it, but for us in this exercise, we're going to determine whether each equation is a function, list 3 ordered pairs that are solutions, and then we'll determine whether it's a function from there or not. So my recommendation is plug in small numbers into equations. So numbers like 1, 2, 3, plug those in. I wouldn't plug in like 35 into an equation because then you're just making it more complicated for yourself. But I would say also like even -1 or -2, right? So from -2 to +2, any 3 of those, 3 of the 5, plug those in, see if it works. Okay, so let's start with 0. Remember, I'm plugging this in for x, and I'm going to do this mentally for now. If I plug a 1 here, 5 times 1 is 5, and then if I add that to 3, we get 8. So 0, 8 is one possible... Oh, whoops. No. I plugged in a 1. 1, 8 is a possible answer. You know what? Let me actually plug in a 0. Okay, if I plug a 0 here, 5 times 0 is 0, and 0 plus 3 is 3. So 0, 3 also is an ordered pair that works out. And then finally, if I plug let's say a 2. 5 times 2 is 10. 10 plus 3 is 13. So I plugged in 3 values. I got 3 outputs. We have 3 ordered pairs. Can we determine whether it's a function or not? This is a function. Each input has one output. So let's just put yes. We cannot map any x to more than one y. So we'll say for now that it's a function. Let's move on to b here. So let's plug in the same things. I'll plug in a 0, right, in for x. 0 squared. So 0, anything squared means, so like 0 squared means 0 times itself twice. So it's 0 times 0. And 0 times 0 is just 0. Okay. Let's plug a 1 now. Right, so 1 squared means 1 times 1. Right? Well, whoops, that's not 2. 1 times 1 is just 1. And then let's say I plug a 2. 2 squared is 2 times 2, and 2 times 2 is 4. All right, is this a function? Looking at the ordered pair, each x has one y, so we'll say that this is a function. Okay, right, and you cannot map an x value to more than one y value, so the same reasoning as before, but let's go to move on to the next page, which is some more practice here with other terms or other operators that we might or might not be familiar with. So let's look at, we're going to work through all 4 of these, but let's look through C. This reads y is equal to the absolute value of x. Now, it might have been a while since you talked about absolute value, but an absolute value, let's say the absolute value of 5. What does this mean? Okay, if I draw a number line here, 0, 1, 2, 3, 4, 5. Also go in the opposite direction. 1, 2, 3, 4. This is a negative 5. Absolute value of 5 is 5 because what the absolute value represents is distance. So what we're saying is how far is 5 away from 0? It's 5 units. And then similarly, absolute value of negative 5. Right, you're looking at how far is negative 5 from 0. Right, if you look from here to here, it's also 5. So some students think that absolute value just makes a number positive, and true, right? We always measure distance as a positive number, but you're always just looking at what is the distance it is from 0. Okay, so getting that out of the way, let's plug in some numbers. If I plug a 0, how far is 0 from 0? Well, it's not far at all. It's exactly that same point. And let's plug a 1. How far is 1 away from 1? Or sorry, 1 away from 0? It's 1 away. And then you know what? I'm going to plug a negative 1. How far is negative 1 from 0? Right, negative 1 from 0, that's just 1 unit. A positive 1 unit. So is this a function? Does each input have one output? In this case, it's yes, right? Because an input of 1 gives me an output of 1. An input of negative 1 gives me that same exact output, but that's fine if we have the same output. So does every input have one output? Yes, this is a function. Okay. Now, typically we'll plug in x values and determine the y values. This might work a little bit differently for D. So for this, we have x squared plus y squared is equal to 1. So we need to think about which 2 values that if we square them and add them together, they equal 1. So I'm going to give you an example. 0, 1 work out. So let me write this above it. So 0 squared plus 1 squared is equal to 1. 0 squared is 0. 1 squared, 1 times 1 is 1. And 0 plus 1, right, equals 1. So that's a true statement. Okay. For this, let me give you another one. Let's say 0, negative 1 also work out, right? So if I put this in parentheses, 0 squared plus a negative 1 squared, this equals 1. The reason 0 squared, we already said it's 0, but negative 1 squared, this means negative 1 times negative 1. Now we know that a negative times a negative is a positive, and 1 times 1 is 1. So it's a positive 1. So it's exactly the same result as we got in the last one. 0 plus 1 is 1. Okay, so this also works out. And then let me give you this last one here. Let's say, let me switch them. Switch that first one. 1 comma 0. If I put a 1 here and a 0 here, 1 squared is 1, 0 squared is 0, 1 plus 0 is 1. So looking at this and testing these points, we can see that it is not a function. And specifically right here, we're saying that when the input is 0, the output is 1. But I come back the next day, I press the button for 0, I don't get 1 anymore. I get a negative 1. So this is not a function. And this is when x is equal to 0, we'll put comma, y is equal to 1, and that y value is equal to a negative 1. So when the input is 0, the output is two different outputs. Okay, so does every input have one output? No. Okay. All right, and then these last two, E and F, are special cases here. E. Now, in order for us to determine an equation is a function, we plug a value for x. But notice for this, we do not have an x value. So what this does say, though, y is equal to 4. The y represents the output. So what this rule says here, it doesn't matter what input you have, the output will always be 4. So, like, let's say I plug in a 1. There's no place for me to plug a 1 at all, but I know that the output is going to be 4. Okay. Let's say I plug in a 2. There's no place for me to plug in this 2. I know that the output's going to be 4. And last, I plug a 3, same output of 4. So is this a function? Does 1, 2, and 3 all have one output? They do all have one output. They all happen to be 4, but this is still a function. All right, this is the Hot Cheeto example where every single button gives me Hot Cheetos. Every single button here gives me a 4. You cannot map an x value to more than one y value. So we're just going to say each x has one y. Okay. And then lastly, f here. So x is equal to 2. Now, there's no place for me to plug a y, but remember, the x represents the input. So what this says is the input is always 2. So I can pick, I'm going to put x, the x part of equal to 2. I could pick any y value. Let me say 5. 2, 5 satisfies this equation. But there's no place for me to plug a 5, so I can make that up. Like, similarly, I could say 2 is equal to negative 5. Or 2 is the input for 10. Right? Since all the x's are the inputs are 2, it works out. But this means this is not a function. I'll put no. We have multiple outputs. Multiple outputs when the input is 2. And you can try to graph this. You can put this into a graphing calculator. X equal to 2 is a vertical line, and as we know, right, anything that's vertical cannot pass the vertical line test. Okay. All right, and we're gonna forego this example. Let's move on to the next page and final page for Talk the Talk, and we'll get to our assignment. We have this graphic organizer, and we're just gonna give some examples. Hopefully, just kind of put all our notes into one place, and this will help us when we move on to our test, which is probably like 10 days from here. Or maybe a week and a half, close to a week. A function, what is the definition of function? What's a characteristic, an example, and then a non-example? So let's start with the definition. In the simplest terms that I can put, a function it's a relation between the set of inputs and outputs, but this is where each input, right, in the domain has one output in the range. Right, remember the range is a set of all outputs, the domain is a set of all inputs. What are some characteristics of a function? Well, let's actually put that to add some key vocabulary terms. So functions have a domain and range. Right, where we have inputs and outputs. If we, for the vertical line test, we'll put VLT. This means that in order for it to be a function, a vertical line can only pass through that graph only once, right? Hence the one output. And then the last thing is right, the x values of a function map to one only one y value. Okay, anyways, but let's actually give some examples though. So yeah, we'll put one of a graph. Let's put quadrant 1 of a coordinate grid. So an example of something that is a function is like this right here. Actually, let me put that in red. Okay, like that. If I have a vertical line, it would only pass that red part only once, so that is a function. An example of something that is not a function, let's say we have this point here, and this point here. Would this be a function? This would not be a function, because if I have a vertical line through here, it would intersect this discrete graph, these 2 points, more than once. Okay, so this is just one example. Anyways, we'll call it there for the activities, but let's get to the assignment. The assignment is all the practice, number 1, everything on number 1. Number 2 is just one part, and number 3 we have 2 graphs determining a vertical line, or determining whether it's a function through the vertical line test. Okay, so let's get started on that. There we go.